So my name is Michael Brown. I'm a manufacturing specialist here at AWS, a solution architect. I've actually been here almost 4.5 years, and prior to that, in a past life, I spent a little over 15 years as a process control engineer, working on the plant floor, worked for systems integrators, and then I moved on from that and ended up working for two large industrial automation companies, one being Wonderware, which is an industrial software company, and the other being Rockwell Automation, which is North America's largest automation company. And somehow, through no act really of my own, I ended up back into IT and cloud. So now I get to focus on manufacturing and industrial customers and helping them to adopt cloud. So real happy to be here today. So if you got any questions or anything, please raise your hand or put it in the chat, and somebody interrupt me. Really like to be able to answer those questions. But at a high level, what we're going to talk about today is we're going to kind of talk about Amazon and manufacturing, right? Maybe that's something you knew existed, or maybe it's something you didn't. But does Amazon know manufacturing, right? We'll talk about that. And then we'll talk about, we'll kind of set up the problem, right? What manufacturers are focused on today, and the challenges that they're facing and the complexity that they're facing. And then, we'll show you what Amazon is doing to try to address some of those, right? We're going to pick two things today. We're going to look at specifically Amazon Lookout for equipment and talk about how it's used to lower the barrier of entry for AI and ML and manufacturing. And then we'll talk a little bit more about AWS Monitron, which lowers the barrier even further. All right, so let's get started. All right, so why AWS for manufacturing? So if you come from a manufacturing background or have been involved in it in the past, you might go, well, there's a lot of companies in manufacturing that I would normally call, and AWS might not have been on that list. I like to think about it as, does Alexa know manufacturing? And the answer is yes, she does. And if you've got your speakerphone on, she probably just woke up. Tell her to go back to sleep. But AWS was born from a company, Amazon.com, the retail company, that has a large, global, and complex industrial automation need, right? So if you walk into an Amazon fulfillment center, I think you guys have done like a virtual tour of the fulfillment centers. When they're open back up for public, please, if you get a chance, go visit one. But when you walk in, you see miles and miles of conveyor systems, and underneath that there's motors and drives and PLCs and vision systems and just massive amounts of industrial automation. It's the same industrial automation that our customers use in their facilities. And we've gone through a lot of the iterations of technology and software that that our customers are using, and that company has really, they're a customer of AWS, and they put a lot of demands on AWS, a lot of complex demands on AWS. So what that does is AWS ends up investing in manufacturing specific solutions. That brought on additional customers like Koch Industries and Georgia Pacific and Invista and 3M and Volkswagen. Again, very large, complex manufacturing organizations really putting demands on the AWS platform, saying, these are the types of things that we need. And what that does is that breeds more opportunity for customers to come in. You say, okay, well, what kind of investments? Just in the last year, these are the types of things that we're talking about. So, we talk about AWS SiteWise, IoT for SiteWise, which is a dashboard for being able to ingest and model and put context around industrial data, and then be able to build dashboards for it, and make those consumable throughout the enterprise. We've got AWS Panorama, which is a physical appliance that goes on premises and allows you to do vision systems using existing cameras. So if there's existing cameras in your facility and you want to be able to use them for machine learning or computer vision applications, and Panorama is a device that we sell that can help you do that on premises. Then we've got Lookout for equipment we're going to talk about today for being able to take industrial sensor data. We got Lookout for vision, which is another fully managed algorithm for being able to do computer vision on the plant floor. So we basically take something like Panorama and we make it, we put more context around it and enable customers to do things like, layout detection, stains, look for, defects in products. Just a broad range of computer vision applications are available through the Amazon Lookout for Vision platform, and then Monitron that we'll also talk about today. Other investments that we're making are things like machine downtime monitoring. So this is a solution. It's a free solution. We don't charge for licensing or anything, but it's a solution that allows you to deploy it into your own AWS environment, and you can just start feeding machine state data into this pattern, and it comes with a web UI. It comes with reporting and QuickSight that allows you to quickly go from really nothing to being able to do machine downtime tracking very, very quickly, right? So that's a free pattern that's available. We continue to invest in these types of patterns for our manufacturing customers to be, one, a lighthouse to kind of show how we do it. This is free and available on GitHub, to be able to take apart and look at it. You can use it as is, or you can include it in your own solutions. And then finally, when we talk about manufacturing, we have to talk about where the data lives. There's many use cases to where the data does not need to leave the four walls of the plant. It needs to stay inside the plant, right? So it needs to stay at the edge. Some applications would allow that data to go to the cloud, right? But we're cognizant of those use cases, and we're building more and more capability into our platform to be able to meet more and more of those use cases. So if you start on the far right-hand side of this diagram, we see, two software offerings, called IoT Greengrass and Amazon FreeRTOS. These are pieces of software that run on the edge. And then as you move further to the left, specifically speaking about infrastructure, we have AWS Snowcone, which is a small compute device that has storage and Wi-Fi and compute capacity on board that can be used. We also have AWS Snowball, which is a larger industrial compute platform and storage platform that we can run virtual machines on. So you could foresee a use case to where we could put industrial applications on a Snowball device and actually just drop it into a plant. And then coming further, we have larger selection. So we have the Amazon local zones. So local zones, I know there's one planned for the Atlanta area. There's one planned for Miami. And a local zone is just a smaller AWS set of resources that's physically located in these cities, and they tie directly to AWS larger regions. And then we also have the AWS Wavelength platform, which is based on our 5G partners. So, putting AWS resources within the 5G so that if you're using that mobile platform, you're going to have single-digit millisecond latency from that platform. And then finally is the AWS Outpost platform, right? We're investing in the ability for our customers to actually deploy Amazon infrastructure in their own data centers, right? And be able to use the same APIs, the same tools, the same capabilities. And when they go to deploy, they can point it to their Outpost implementation and not an AWS region. All right, so when you look at this, we're really trying to provide more choice and more capability to run the workloads where appropriate and not have to just force everything into one model. So let's go one level deeper and let's look at a high level, the machine learning stack inside of AWS. So this is important. Just a few years ago, the idea of doing something with machine learning was very complex. You had to understand what libraries you wanted to use. You had to understand the languages you wanted to use. You had to be able to, getting the data out and preparing the data, cleansing the data, making sure there's no zero values. Doing all of that work was almost like a separate job. And then you had to build the machine learning platform. So it's really only ready for, scientists and academia. What we've done at that level is we've started offering services at that level. So if you have knowledge of machine learning and you know what you want to use and you have a custom deployment that you want to do, we offer a machine learning framework and infrastructure platform at this lowest level. So if you have expertise in this area, we still lower the barrier of entry, right? We make it easy for you to get your platform stood up quickly with the services and the servers and the resources that you need, and start working on your data and working on your models. Now, if we want to lower the barrier a little of entry a little more, we go up one level and we talk about our machine learning services called Amazon SageMaker. So this is a full development environment that helps you both prepare the data, label the data, and then gives you just a plethora of options to be able to train and experiment with different models to get the best outcome, with the data that you have, right? So we give you the ability to do that with a machine learning modeling platform called SageMaker. And then at the layer above that is what we call our AI services. So think of these as fully managed, containerized models that all you have to do is you don't have to worry about the infrastructure. You don't have to worry about the training of the models. All you have to worry about is getting the data in the correct format and letting the models take charge, right? So if you look at these, we've got models, there's services specifically around text and speech and vision, forecast, fraud. And then the services that we're looking at today are going to fit into this higher level, right? This level at the top. So the first one I'm going to talk about is Lookout for Equipment. So if you think about what we're doing here, Lookout for Equipment is a platform that's used for customers with existing sensors, so existing equipment with sensors already on it, right? And we want to be able to take that and do something with it. But the first challenge starts with the complexity of industrial environments. So when you go into an industrial environment, if it's not something that you've got a lot of experience with, when you walk in with these plants, all of that equipment, it's not all new. It wasn't all bought at the same time. It's at various ages, it's various conditions, various generations, and it's been built over time. If the company has they've been in business for a while, it's been built over time organically. And a lot of the common technologies, like every so often, there's just a new technology that comes out, and that's bought and integrated. And we start looking at the complexity of that. And let's take this technology stack from the bottom to the top is what we call the operational or the manufacturing technology stack, operational stack, OT, you might have heard it referred to, and manufacturing technology. So at the bottom is going to be your machines and the raw sensors. And then at the level above that is going to be these embedded controllers called programmable logic controllers and HMIs, human machine interfaces, so the touch screens or the displays that the operators use. And then above that, a lot of manufacturers go, you know what, we need to tie some of this data together, and they buy or invest in a supervisory control and data acquisition system or a SCADA platform that tries to tie some of this together. And then above that, we have a specialized database called Historian. It's time series based. It allows you to collect historical data on all the process variables and things that are happening in your plant. And then we go up to a manufacturing execution system, which handles the scheduling and the planning and the inventories and the work instructions and all of the things that go around, planning to make something and then the execution of making something. And this varies across. And then at the top, you've got the enterprise resource planning software platform, right? So the ERP and traditional IT space. The complexity comes when we start going, okay, well, how do we get data? How do we get real-time data and real-time insights? We have to start integrating one at a time. So we integrate machine sensors into the PLCs and the SCADA platform, and then we integrate all of that into a historian, and then the historian and the SCADA platform gets integrated into the MES, and then we make some integrations into the ERP. Okay, well, that's great. That's what we've been doing for 40 years, for on and off. But the problem is each one of these integrations is a one-to-one integration endpoint, and there's entire ecosystems and cottage industries of systems integrators that this is all they do. But unfortunately, the complexity grows, right? It's not just that one stack. It's that one stack all over the place. And this might just be in a single building or a single plant. Right? We start integrating different things. And the reality is if you've got multiple plants and multiple systems, you might have different ERP platforms, you might have different MES platforms, you might have quality and work management systems, warehouse management systems. It starts becoming very complex. So when we want to have an impact, we've got to make it easier to get the data, make it available, and provide results. So what does that look like specifically in the world of maintenance? So here's the four, the four areas of maintenance, if you will. First is reactive. And for, when we think about assets, manufacturing, when we think about assets, assets are, they go from inexpensive and easy to repair and, not very mission critical, all the way through mission critical, expensive, difficult to repair, right? Or long lead time to repair. And so we balance that with how we want to maintain it. So the idea of reactive maintenance, wait till it breaks, that's actually completely viable. If it's something that's low impact, it's easy to replace, it doesn't cause downtime, I might simply just wait till it breaks, right? And then I'm going to replace it. But most of the time we end up with something of critical value. We end up at least in preventative maintenance. So what that looks like is, you're going to do it every 300 working hours, or every week, every month, once a quarter. You schedule-based maintenance. We're going to do this thing. The asset may or may not need that maintenance, right? But we're doing it on the time-based. The next iteration, which is where we're really trying to get to, where all the focus is now, is condition-based monitoring. So we're doing a lot of that in traditional ways. We're looking at thresholds and alarms. We're looking at, they're doing some statistical analysis on data that's currently available. We're looking at physics-based, like, looking at, the amount of time or the amount of effort, the amount of watts, things that go into these things. But the next iteration is going to be machine learning, right? I want to be able to take all of the telemetry that I have, all of the features, if you will, that I have of the telemetry that tell me the story about my asset. And I want to build classification models. I want to build regression models. I want to build different models that can give me a prediction on failures or a prediction on anomalies, right? That gives me the ability to plan ahead of time. And then that leads us into a prescriptive plan, right? So then we can start, once we build models that have a high enough confidence, we can start prescribing the types of orders that we're going to run, the length of orders that we're going to run, the scheduling, the labor requirements. We can start putting prescriptive ideals around how we're going to run our plant once we can reach a high enough confidence in condition-based monitoring. And if you've ever seen any type of condition-based monitoring, it's a lot of times it's done with vibration, or it's done with sound waves, or it's done with heat in different waveforms. And a lot of times the experts, the subject matter experts that work on this stuff, they see these types of charts and they do their regression analysis and find out. So for most people, me included, I look at something like this and I go, I don't know what that is. Right. But the idea is we want to be able to easily get to a format to where anybody can make an assessment and go, you know what, that doesn't look right. Let's get a subject matter expert. Let's get a maintenance engineer to go take a look at it. Other areas that we're, that make this really conducive is, we look at, number one, we want to prevent downtime, right? If I'm running a product, if I'm in the process of running it, it just stopping out of the blue is it's bad, right? It's not a great way, and that causes downstream processes to fail. It causes product to back up coming into it, right? We don't want unplanned downtime. If we can plan for it, that's one thing. We want to minimize the risk of that happening by better understanding the condition of our assets that we have, right? We want to reduce the risk of failure, and process in looking at process anomalies could lead to work safety or risk, or work safety risk or containment risk. So if we understand our assets better and we understand how they operate, we can also reduce risk around work safety. Quality issues. If we see anomalies and we have difficulty with our machinery, that could also be contributing to quality issues that we're building, right? So we want to be able to reduce that risk as well. And then finally, just being able to better understand operations, right? And optimize throughput and optimize inventory based on where a piece of machinery is in its life cycle. There was a report that McKinsey put out in 2000. When was that? I think 2019. It wasn't last year. It was in 2019. Part of their Beyond the Hype report, that they made the statement that that advanced maintenance has the potential to save companies over $600 billion by 2025, right? So just going one level deeper than scheduled maintenance can really start impacting how customers are doing, especially when you're looking at the supply chain issues and the demand issues that we have today. Being able to keep your equipment running and running longer is extremely important. All right, so let's look specifically at what Lookout for Equipment does. So think about it this way. We want to be able to take data that you already have, right? And we want to meet it. We want to meet that data where it lives today. So, we don't want to have to go and buy all this infrastructure to make this happen. So what we look for is it can be as simple as uploading data, right? It's that simple. I take data that I have that's historical time series. So I want to see the if you remember that diagram from earlier, the historian or the SCADA platform, I want to be able to extract data from that, export it into a CSV file or something similar. And then I want to take maintenance records if I have those, right? So when was it taken out of service, or when was it last updated, or when was the last anomaly, right? We want to be able to take what we know to be times when there were anomalies or times when there were issues. And unlike, personally, my first thought was, oh, we definitely want to be able to label when there was issues. Nope, that's not what we want to do. We want to show the model when it runs perfectly, right? We want to show the model when it's operating correctly. So really what we want to do is we want to remove, quote, label the data, and we want to remove all the areas to where there was an issue, because we don't want the model to know what an issue looks like. We want it to know what good operation looks like. And then once we give that data to the model, then it actually starts just providing anomaly detection for us. So we take that data, we put it into Amazon Simple Storage Service, Amazon S3, and then Amazon Lookout for Equipment will actually take that data and train it, and it'll generate a machine learning model. And then we can actually use an inference API, so we can actually schedule it. We can turn it on and leave it, or we can schedule it to run during operating hours. And that gives us a real-time endpoint to be able to take real-time telemetry data and send that through the endpoint, so that it's actually given us a prediction on an anomaly detection and predictions. Then it takes that inference results, so it's taken the results that it's calculating in real time, and it stores those back into S3 so that we can go and look at it and evaluate it. So if we see something that says an anomaly, and we go, okay, yeah, that was an anomaly, and so that's good, right? That was a good response. But if we see something that maybe Lookout for Equipment said it was an anomaly, but our engineer says, no, that wasn't really an anomaly, that was something that was good, we can go and label that and then retrain it, right? So we can easily enable the ability for engineers to refine the model and make the model better over time. Lookout for Equipment is built for a wide range of industrial equipment. So it's, we really want to, whether it's, discrete or continuously operating, whether it's new equipment or old equipment, right? We want to be able to take the sensors and the telemetry that you currently have, or maybe IoT sensors that you can add after the fact, and be able to take those and build models to help give you additional insights. So what does it look like traditionally? And many of our customers that are currently on the platform have done this process, right? We're not going to jump into all of them, but we take the input data, like that data preparation that I was talking about earlier. We take that, and then we go through, we set up the timestamps. We do we do imputation, and we do cleansing. Then we do algorithm selection. Algorithm selection might be multiple algorithms. We might try 3, 4, 5, 6 different kinds. Then we tune the parameters, and then we set thresholds, we validate it, then we go through all of the different iterations and modifications, and then finally we get this output evaluation in action. Again, this is something that our customers can do if they want to customize a model. If they've got something super specific that they want to operate on, they can actually continue to do this, right? This becomes a viable option that we provide capabilities for. But with Amazon Lookout for Equipment, you give us the data in the format we ask. We build the model, and then you have an inference engine that you can use for output and action, right? And so it turns into the engineer You have an associate or an engineer that monitors, a single or multiple sites. We can actually put that in visualization. There's multiple options for that. When they spot anomalies, they can use that to diagnose. So think about it. We don't know, the modeling doesn't know what you're building, right? It doesn't know your application. It just knows that this is what it's supposed to look like when it's operating correctly. And I'm seeing an anomaly, right? I'm seeing something that's different from what a normal operation looks like. And so you still require subject matter experts or operators, and the operators use their knowledge of the process. This becomes a force multiplier for them. So they don't have to do all of the work themselves. They say, okay, there's an anomaly, and they can go and immediately look at what might be happening. Then engineers are able to automate the decisions and begin, to do plans around, when you see the anomalies and what the anomalies mean. And then finally, the engineer is able to provide, model input or feedback, right, so that we can continue to train this. So what does that look like for people when we're looking at this? So let's take the idea of a pump, right? So a large pump in this case, up there in the upper right corner. Let's look at this axis. As we look at the bottom going from left to right, we see the flow rate. So think about something in gallons per minute over time, right? And then going up the left-hand side, going up that axis is the speed of the pump. How many RPMs or revolutions per minute is happening? So when you think about it, at low speed, we should have a low flow rate. And at high speed, we should have a high flow rate. High and low are indeterminate, depending on it. It could be thousands of gallons or tens of gallons, right? But the idea is we're looking for anomalies, right? So if we plot a bunch of data points and they kind of cluster around low RPMs and low flow rates, and that's kind of linear as RPMs go up, flow goes up, the algorithm's going to detect that. And then if we see something that's an outlier condition, we start seeing things like high RPMs and low flow rates. That's an anomaly, right? So Amazon Lookout for Equipment, when you don't have to go and figure all of this out yourself. The managed service actually runs through 28,000 parameters and unsupervised techniques for up to 300 tags. So you can take 300 features for a single piece of equipment, and it's going to iterate through 28,000 combinations to come up with an optimal machine learning model for inferencing. Got to skip through this. ML surfacing. So when it does detect an anomaly, it doesn't just go, yes, there's an anomaly. No, there's not an anomaly, right? That's traditionally, right? We get a binary 0 or 1 that there's an anomaly, and it requires an expert to go and figure it out. Lookout for Equipment actually gives you a ranking, right? It says, okay, here's the things that are contributing to the anomaly, right? Here's what we're looking at when something is providing an anomaly. So in this position, you look at it, you've got the variables, pressure, vibration, flow rate, RPM, and temperature. It's actually going to stack them and say pressure is the highest, followed by vibration, and followed by flow rate are the highest contributors to this anomalous behavior. So you're going to get full feedback. Different applications for Lookout for Equipment. So there's a lot, right? So everything from power and energy and renewables to process and discrete manufacturing. Really just, let's meet your data where it is and, build models and do experimentation. Because the idea here is we don't have to build out a lot of infrastructure. We don't have to build out a lot of capabilities. So the risk of experimentation is extremely low, right? Even if we don't have continuous flow from the plant, like in an ideal situation, you can extract data in batch and upload it in batch and do experimentations, right? So it's very, very low risk to try. Talk about data lake. So Lookout for Equipment has higher, there's additional capabilities, right? So once the data goes into S3, and then the auto ML service, Lookout for Equipment, is consuming that, right? You also have the ability to, because that data is sitting there, you've effectively built or started your industrial data lake or industrial data platform. So that industrial data both the raw data that was used to build the model and the new data that's coming in through inference in the results. That data is available for alarms, for predictive analytics using downstream and upstream. It could be used for additional dashboards, used for scheduling and planning optimization. So it's not just we put the data in S3 and then we just get to use this one service. It gives you the opportunity to start building on top of itself. So that's a lot of work, but less work than doing it yourself from scratch. So let's take a look at what it means when we do something like Amazon Monitron. So let me drag something over. So just right off the bat. So here's Amazon.com. This is Monitron. You can buy it off Amazon.com. It comes with a gateway and 5 sensors for the starter kit. You can buy sensors in 5 packs. You can buy additional gateways individually. The main goal of Monitron is we want to democratize the ability to do anomaly detection and machine monitoring on the plant floor, right? We want to make it super easy to go from I have absolutely nothing to I'm doing monitoring very, very quickly. And Monitron is the platform that we're using for that. When we look at the industrial maintenance, industrial maintenance, machine learning is something that everybody aspires to, right? When we talk to customers, they say, what are the top things that you're looking at? They're like predictive maintenance. Yep, that's it. But there's normally a couple of steps that you have to go through to build out a predictive maintenance practice. Traditionally, if you go into the plant where companies are doing predictive maintenance, they've got a predictive maintenance platform. It's because they've got a service provider who comes in and they either manage the monitoring of the high value equipment, they manage the vibration analysis, or they go around and they actually walk around and manually measure all of the critical assets, and then they do the interpretation of the data and provide it, right? So it's a scope of work or an SOW. So the idea of I can just buy some sensors off Amazon, glue them to my equipment, and start getting anomaly detection immediately, it significantly makes it easier to be able to do that with critical equipment as well as less and less expensive equipment, right? So it makes it easier for large enterprises as well as small manufacturing operations to be able to do this. All right, some click problems. So we talked about machine learning went from being aspirational to mainstream, right? Or we're trying to make it mainstream. For a long time, the technology was limited to just a few major companies. But with products like Lookout for Equipment and Monitron, that's really starting to change, right? So the compute power and the data becomes more available. Literally, machine learning is getting easier and easier to use, and so. When we look at going from this reactive to, planned maintenance to predictive, you can literally get started now. I think I covered that a little bit. Let's jump right into Monitron itself. So this is how it works, right? This is what it looks like. You buy the kit. It shows up. Amazon, if you got Amazon Prime, it's Prime delivery. You get the devices. So the devices, you actually use a like Loctite or some sort of adhesive to actually apply the devices to your motors or your pumps or your bearings or your fans, those types of things. You install them, and then you use currently an Android phone, right? So it's Android. We've got an Apple iOS app under development, but you pair the sensors to the gateway with the phone, and then the gateway to your AWS account. Once you do that, you actually, you tell the app that what piece of equipment the sensors are a part of, and then once you finalize that configuration, it goes into a learning state, and so it's just sitting there watching the application, watching the equipment, and emitting that telemetry directly to AWS through an encrypted link. And after that training period is over, a couple hours, a couple of days, it'll let you know. It says, okay, yeah, we've gotten enough data that we can go into online monitoring. Now you can actually use the phone app to look at what's going on. You can get email you get notifications through email or SMS. It allows you to very, very quickly be able to see and monitor the operation of equipment, everything that you've got this platform on, as well as be able to mark anomalies, right? So you can get the feedback directly there in the app, right? So it gives you a very, very low threshold of entry to be able to get machine data. We use the ISO and ML-based analytics, standard rules for doing machine detection. We give timely notification through the app. Again, it's super simple to use. I've actually, one of my colleagues here at AWS, he actually bought a kit and he installed it on his milling machine and his grinding machine and his sanding machine, because he makes knives as a hobby, and he actually installed it on that machine. So he's like, this is really cool. So you can see when his machines are working hard. And it's fully managed, right? So we don't have servers to build. One of my colleagues likes to say no EC2s were harmed in the making of this application. Super easy to set up and get going. Build this out. So motors, gearboxes, something I might not have said, I want to make sure that I say it, is Monitron, unlike Lookout for Equipment, Monitron is best suited today for rotating equipment. And if you think about it, most equipment is driven by a motor, and that motor maybe is hooked to a gearbox, both rotating equipment, has a lot of bearings, rotating equipment. Even if it's doing like a piston in and out, right? Behind that somewhere is probably something rotating. So when you start to look at it, bearings, fans, compressors, motors, shafts, all of these types of things across all industries are available for monitoring. It's simple, right? It doesn't require any machine learning knowledge, any development work, any coding. You can, literally anybody can use it. It's cost effective. The kit's like $715 per site, to get started, and you can add up to 200 device or 200 sensors to a single gateway. We see, we see customers using, you can, I think 20 sensors per piece of equipment, right? So you can scale that out. It's fully secure from scratch. It's totally encrypted, one-way communications, and we're continuously improving the platform, right? It's not just what we have today, and then when the next version comes out, you've got to buy it. We're continuously improving the model. We're continuously improving its capabilities. Like I said, we're adding capabilities to the mobile app itself. And so once you get it, you're going to continue to get the investments that we continue making around manufacturing. One of the customers that was an early adopter is Fender, the musical instrument manufacturer. So Fender is actually using this for some of their pumps and motors. So think vacuum pumps, that are pulling things into place and like forming things. So vacuum pumps and motors, they're using Monitron to be able to do machine downtime or machine and anomaly detection. And then the other one is GE Digital. So they're actually using this on some of their tumblers and polishers on their turbine component manufacturing. So again, they also use Lookout for Equipment. So being able to use both of these capabilities together really makes it easy to get telemetry where telemetry didn't exist before. So the process, you buy the sensors in the gateway, you configure and install them, and register the equipment, and then you just start monitoring. For larger deployments, I will say you can actually buy these through PO, through Amazon Business. So you can actually get that set up. You can reach out to your Amazon account team. We can walk you through how to do that. All right, that was a lot. Anybody have any thoughts, questions, comments?
That was awesome, Michael. Thank you very much. Justin from Trent Micros here. He's got just a little extra incentive to jump in the conversation with any questions. He's got some Uber Eats gift cards to give away, but we'd love to hear your thoughts on what Michael's presented here, ideas of where you think you might find some cool implementations of it, or any questions you have for him.
I have a question. Did anybody here realize that Amazon was this deep into manufacturing?
I certainly didn't.
No. So, well, what do you do? Do you set a baseline with these sensors? Is there a way to automate? Okay, now that we have a baseline of what telemetry we're supposed to get when everything's working properly, and then you can set tolerances to see when it when some small thing happens to where the telemetry changes, to where it's clear that we can infer from this telemetry that something is going to break in the machine. Is that automated to tell you to do that, or do you just have to keep looking at the data to say, okay, the telemetry we're getting now, we can clearly see that there is something amiss inside the sensor from it vibrating too much now or something else? Like, how does that work?
Yeah, that's a fully automated workflow. So you take the little sensors and install them on the equipment. And then initially it goes into a learning phase, right? So you don't want to do it during, you don't want to install the sensors and set them up when you're not going to be running the equipment. What we're really looking for is you install it and you're running the equipment, right? The equipment's running and doing what it's supposed to do. And during that learning phase, it goes, okay, it checks the baseline on its own. And then at some point in time, the algorithm goes, I think we have enough data. And it kicks over to monitoring mode. And then if you see anomalies, you can actually provide feedback directly through the app about what's going on. If that was an anomaly, that wasn't an anomaly, you can give it feedback. And then it gives you notifications when there is anomalies. Now, it's up to the subject matter expert to understand what that anomaly means, right? We're just going to show an anomaly, but it's up to the operator or the maintenance engineer to go, okay, I see an anomaly. Let me go check out what's going on here, and now I can see, now I can see what it is. So it's, it still requires some subject matter expertise to be able to effectively use these platforms, and I think that goes for all of them.
So it gives itself an automated baseline, and then you kind of tweak it and fine tune it, and then after so much implementation of it doing its thing and you helping it, you kind of have a baseline to where you're pretty automated, and you can have a really good preventative maintenance program to where you really never have anything down and all you're doing is preventative maintenance.
That's right. That's exactly right.
That's crazy. Sorry, I used to do maintenance and stuff, so it's just crazy to me.
Yeah, we've actually got customers that, when like, so look out for equipment, it'll say things, it'll give you predictions, right? It'll say things like, hey, there's an anomaly here. We think it's in 32 hours, there will be another anomaly, right? So it starts giving you predictions based on what you're doing. Some of the customers who've built more customized models, Georgia Pacific, for example, they're able to predict 60 to 90 days out for failures, like at 60 to 70% confidence. So what that means for them is they're looking at this and they go, okay, they kind of look at it a couple of different times. They go, okay, I see an anomaly, and then some what I'll call power users, right? They'll vet that anomaly, right? They'll kind of tear it apart. They won't sound the alarm yet. They'll kind of poke that anomaly, and then if it's consistent, it's plus 60 days. Then they'll contact the maintenance department at that site and say, hey, could you go check this out, right? And then the maintenance engineer will go and do what they normally do, and they'll go, you know what? Yeah, the packing on this bearing, it was heating up, right, or something, But it allows them to catch things much. We're not talking minutes here. We're talking days and weeks and sometimes months ahead of schedule.
Can you do this in the transportation to localize it to rear ends, transmissions, engines, different parts of large trucks or heavy equipment?
I've not seen that, but I don't see why not.
Okay, cool.
That would be a cool use case, Justin. We need to get some cloud folks to see what they think. Anybody else? Great question so far. Anything else Mr. Brown can address for you all? All right. Well, with that, we can wrap up for the day. I've posted all the links we talked about earlier into the chat. Don't forget to sign up for some cool AWS swag from Karna and upcoming AWS training events we'd love to direct your attention to. And of course, videos of this and all of our other sessions always end up on our YouTube channel a few days afterwards, along with yesterday's Huntsville session. So thank you all again for joining. Again, huge thanks, Michael, for sharing your time with us and doing this. This was an amazing presentation. So I hope a lot more people will share this after the fact and go look at this. I think there's some really cool, just you're right off the shelf, easy ways to get in learning and applying this, which is really the biggest takeaway that we ever want, is that these technologies are accessible. You can do them. You don't need extensive prerequisite experience or even equipment and knowledge to do this. So thanks for very much for shining a light on that.
No, thank you. Appreciate everyone.
All right. Hope everyone has a great weekend, great long holiday weekend, actually. And we look forward to seeing you all back in Huntsville and Birmingham meetups in June.